Auzu billahi minash shaitanir rajeem. Bismillahir rahmanir rahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar, and you will come back to this study. Dear students, you know in the last two lectures we have learned about Newton forward difference interpolation formula and Newton backward difference interpolation formula for polynomial. And today we are going to learn about numerical differentiation based on Newton forward difference interpolation formula. And this is the second lecture of third week for this course, numerical analysis. Since we have to find the approximate derivative of a function based on Newton forward difference interpolation polynomial. So first of all, I would like to tell you again about Newton forward difference formula. Suppose we are given the following values for the function y is equal to f of x for a set of values of x, for example x is equal to x0, x1, x2 up to xn, and the value of y for x0 is y0, for x1 is y1, for x2 is y2, and so on. The value of y for xn is yn. This data is equal space data. I have already told you about Newton forward difference interpolation formula and Newton backward interpolation formula, that these two formula working for equal space data. Now we assume that the approximate derivative of the function exists. So replacing the function y of x by Newton forward interpolation polynomial, which is called Newton forward difference interpolation formula. But here note that why we replace the function y of x on Newton forward difference interpolation polynomial? Because we have to find the approximate derivative on the basis of Newton forward interpolation polynomial. So what is a Newton forward difference interpolation formula? The Newton forward difference interpolation formula is given by this expression: yp of x is equal to y of x0 plus ph, which is equal to 1 plus p delta plus p into p minus 1 whole divided by 2 factorial delta square plus p into p minus 1 into p minus 2 divided by 3 factorial delta cube plus and so on, p into p minus 1 into p minus 2 into p minus 3 and so on into p minus n plus 1 whole divided by n factorial delta power n into y0. And if we multiply this y0 to this expression, we get another form of the polynomial, which is equal to y0 plus p delta y0 plus p into p minus 1 whole divided by 2 factorial delta square y0 plus p into p minus 1 into p minus 2 divided by 3 factorial delta cube y0 plus and so on, plus p into p minus 1 into p minus 2 into p minus 3 and so on into p minus n plus 1 whole divided by this n factorial delta power n into y0. And if we multiply these two terms and these three terms, we get another form of this polynomial: yp of x is equal to y0 plus p delta y0 plus p square minus p divided by 2 factorial. Multiplied these two expressions, p into p square, and p into minus 1 is minus p divided by 2 factorial delta square y0. And if we multiply these three terms, we get p square minus 3p square plus 2p divided by 3 factorial delta cube y0 and so on. Dear students, note that in this formula this del operator is the forward difference operator, and p is the parameter which is given by x minus x0 divided by h. In the range for p is minus 1 and 1. P lies will be in the range between minus 1 and 1. And since the data is equal space data, so there will be a step size, and this step size denoted by h, which is given by xi plus 1 for I is equal to 1, 2, 3 up to n. Now since we have to find the approximate derivative on the basis of this Newton forward difference interpolation formula, so taking the derivative of this y function with respect to x and using the chain rule, dy by dx will be equal to dy by dp multiplied dp by dx. And since p is given by x minus x naught divided by h, so find the derivative of this p with respect to x. The derivative of p with respect to x will be 1 over h. Since x naught is the constant term, so the derivative of this constant term will be 0, and the derivative of x with respect to x will be 1. So dp by dx is equal to 1 over h. And similarly, dy by dx will be equal to 1 over h dy by dp. Now come to the formula. So taking the derivative of this formula, dy by dx will be represented by y dash of x, which is equal to 1 over h dy by dp. dy by dp mean taking the derivative of the right hand side with respect to parameter p. So the derivative of the right hand side with respect to p will be equal to 1 over h, and since there is no p, so this y naught is constant term, so the derivative of this constant term with respect to p will be 0, and the derivative of p with respect to p will be 1. So we get delta y naught, and using power rule, the derivative of p square will be 2p, and the derivative of p will be minus 1. So 2p minus 1 divided by 2 factorial delta square y naught. And the derivative of this expression by using power rule, derivative of p cube 3p square, derivative of 3p square will be minus 6p, and the derivative of 2p will be 2 divided by 3 factorial delta cube y naught plus, and so on. Now using again chain rule, the second derivative of the function will be given by y double dash of x is equal to 1 over h n to delta square y naught plus 6p minus 6 divided by 3 factorial into delta cube y naught. In general, n time derivative of the function with respect to n time x is equal to 1 over h power n time derivative of the function with respect to n time p. Now to find the derivative of the function on the basis of Newton forward difference interpolation formula, first of all construct the differences table. For the differences table, put the value of x in the first column and the value of y in the second column, and then find the first differences column, second differences column, third differences column, fourth differences column, and so on. For the first differences column, subtract y naught from y1, we get delta y naught. Subtract y1 from y2, we get delta y1. Subtract y2 from y3, we get delta y2, and then subtract from y3 from y4, we get delta y3, and y4 from y5, we get delta y4. Similarly, for the second differences column, subtract each the consecutive terms. Subtract delta y naught from delta y1, we get delta square y naught, and delta y1 subtract from delta y2, we get delta square y1. Similarly, for this difference, subtract this value from this value, delta y2 from delta y3, we get delta square y naught, and subtract delta cube delta y cube from delta y4, we get the difference delta square y cube y3. And for the third differences, column, subtract delta square y naught from delta square y1, we get delta cube y naught, and del square y1 from del square y2, we get delta cube y1, and then subtract delta square y2 value from the delta square y3, we get delta cube y2. And similarly, for the four differences, subtract delta cube y naught from delta cube y1, we get delta 4 y naught, and subtract delta cube y1 from delta cube y2, we get delta 4 y1. And for the last differences, subtract delta 4 y naught from delta 4 y1, we get delta 5 y naught. Now let's move on an example. To find the first and second order derivative of a function tabulated at the point x is equal to 2.31 and x is equal to 3 on the basis of Newton forward difference interpolation formula. This is the given data. For x is equal to 0, the value of y is 2. For x is equal to 1, the value of y is 3. For x is equal to 2, the value of y is 10. For x is equal to 3, the value of y 29. For x is equal to 4, the value of y is 66. And for x is equal to 5, the value of y is 1 27. Similarly, for x is equal to 6, the value of y is 18. There is only one gap between this these values of x, so the step size in this data is 1, and we have to find the first order and second order derivative at x is equal to 2.31, and similarly we have to find the first order derivative and second order derivative of the function at x is equal to 3. This is the given function for this given data. Dear students, we can compare and verify our result with this exact result function. Now, to construct the divide differences table. For the divide differences table, put the value of x at this first column and the value of y at this second column, and then find the first differences, second differences, and so on, third differences. For the first differences, subtract 2 from 3, we get 1. 3 from 10, we get 7. 10 from 29, we get 19. 29 from 66, we get 37. And 66 from 127, we get 61. Similarly, to construct the second differences table, subtract 1 from 7, we get 6. And 7 from 19, we get 12. 19 from 37, we get 18. And 37 from 61, we get 64. Similarly, for third difference, subtract 6 from 12, we get 6. And 12 from 18, we get 6. And 18 from 64, we get 6. Now, to find the value of p, for the value of p, target the value of x naught. Dear students, since I have already told you that in Newton forward difference formula, we take x naught from the beginning in the table. So from beginning in the table, if we consider the value of x naught 0, then the value of p will be x minus x naught divided by h. Since we are going to find the first and second order derivative at x is equal to 2.31, so this is the given value for x. So putting the value of x 2.31 and the value of x naught is 0 divided by h. Step size in the data is 1. So for x naught is equal to 0, the value of p is 2.31, which does not lies in the range between -1 and 1. So change the position for the x naught. Similarly, so if we take the value of x naught 1, then again p does not lies in the range -1 and 1, between -1 and 1. So consider the value of x naught is 2. If we take the value of x naught is 2, then the value of p will be x minus x naught divided by h is equal to 2.31 minus 2 divided by 1. So the value of p is 0.31 at x naught is equal to 2, which lies between the range -1 is 1. Now, by using Newton forward difference formula, this is a Newton forward difference interpolation formula, taking the derivative of this interpolation formula. But before taking derivative of this interpolation formula, first of all, simplify this expression as I have already done in the previous slides, like this. Multiplied these two expression and these three expression. This is the simplest form of the Newton forward difference interpolation formula, and then taking the derivative of this form, then you can easily find the derivative of the expression, which is equal to 1 over h into delta y naught plus 2p minus 1 divided by 2 factorial delta square y naught plus 3p square minus 6p plus 2 divided by 3 factorial delta q y naught. Now target the value of delta square and delta cube corresponding to the value of y naught. Come to the table again. Since in the table the value of x naught is 2, now the value of x naught is 2, and from the beginning the position of x naught is third position. So from the beginning at third position, target the value of y. This is the value of y naught. and from the beginning at third position the value of delta is 19, and from the beginning the value of delta square is 18, and from the beginning the value of delta cube at third position is delta cube. I want to repeat again. Since from the beginning the position of x0 is third position, so from the beginning the value of y0 at third position is 10. From the beginning at third position the value of delta is 19, and from the beginning at third position the value of delta square is 18, and from the beginning the value of delta cube is 6. So using these values y0 10, delta 19, delta square 18, and delta cube 6, which lies on this down diagonals. Now using these values and putting these values in this expression, we get the first order derivative of the function at x is equal to 2.31, which is equal to 1 over h 1 over 1 into 19 plus 2p minus 1. This is the value of p minus 1 divided by 2 factorial, and this is the value of delta square. This is the value of delta square, and this is the value of delta cube. So 3p square minus 6p plus 2 divided by 3 factorial. This is the value of p, and this is the value of delta cube. Now simplify this result. We get 19 minus 3.42 minus 0.42841, which is equal to 16.008. Now to check and verify this approximate result, since the exact function for the table is given by x cube plus 1, taking the derivative, first of all taking the derivative of this function. So the derivative by power rule of this function is very simple. 3x square is the first order derivative, and putting x is equal to 2.31 and this first order derivative, we get y dash at x is equal to 2.31 is equal to 3x square. This is the value of x in whole square is equal to 16.008. Since the approximate derivative of the function at x is equal to 2.31 is 16.008, and the exact derivative result of the function is also 16.008, so there is no error, there is no difference. So our approximate derivative of the function at x is equal to 2.31 is correct. Now to find the second order derivative of the function on the basis of Newton forward difference interpolation formula, find the second order derivative of this expression. We get, this is the second order derivative of the Newton forward difference interpolation formula. 1 over h square into delta square y naught plus 6p minus 6 divided by 3 factorial del cube y naught. And now come back to the table and again target the value of delta square and delta cube corresponding to y naught. Since we consider the value of x naught is 2, since we consider the value of x naught is 2, so we need only two values delta square. The value of delta square is 18. For the second order derivative we need only delta square and delta cube, so the value of delta square is 18 and the value of delta cube is 6, corresponding to these position of y naught and x naught. So putting these values of y naught, delta square y naught is 18 and delta cube corresponding to y naught is 6, and this second order derivative of the function, we get 1 over h square, 1 over 1 square into 18. This is the value of delta square, and plus into 0.31 minus 1 into 6, and the result is equal to 13.86. So the double order derivative of the function at x is equal to 0.31 is 13.86. Subtract common 6 from this expression, and 3 factorial means 6. Cancel 6, so with this 6 we get p minus 1. This is the value of p, so p 0.31 minus 1 into the value of delta cube into 6, and then after simplification we get 13.86. Now since the exact function for the given data is x cube plus 1, so First, find the first order derivative of the function by using power rule 3x square, and now find the second order derivative of the function by using power rule. We get 6x, and putting the value of x 2.31 in this given function, 6 into 2.31, multiply 2.31 into 6, we get 13.86. Now for x is equal to 3, find the first order derivative and second order derivative of the function at x is equal to 3. Dear students, this is a home task for you, but I want to tell you about only for the value of x naught and for the values of delta, delta square and delta cube, and then you can put these values in the given formulas. You can easily calculate the approximate value of y dash and y double dash. Since the value of x is 3 now, to find the value of p, target the value of x naught. If we consider the value of x naught from the beginning in the table, which is x naught is equal to 0, then the value of p does not belong to in this range between -1 and 1. Similarly, if we consider the value of x naught is 1, then p also does not lies in the range between -1 and 1, and for x naught is equal to 2, the value of p also does not belong to the range -1 and 1. So if we consider x naught is equal to 3, so if we consider x naught is equal to 3, then the value of p will be 3 minus 3 divided by h value is 1, is equal to 0, and 0 lies between this range. So using this value of p0, to find the first order derivative of the function on the basis of Newton forward difference interpolation formula. This is the first order derivative. 1 over h into delta y naught plus 2p minus 1 divided by 2 factorial delta square y naught plus 3p square minus 6p plus 2 divided by 3 factorial delta cube y naught. To target the value of delta, delta square and delta cube corresponding to the value of y, the value of x naught, come back to the table. Since this is the value of x naught, the value of x naught is 3 in the table from the beginning. This is the value of x naught from the beginning. The value of x naught is at the 4th position. So from the beginning, target the value of y at 4th position. So this is the value of y naught, and target the value of delta from the beginning at 4th position, which is 37, and the value of delta square from the beginning at 4th position is 24. So we need only the value of delta, delta square, and also the value of delta square is 24, and the value of delta is 37, delta square is 24, and delta cube is 6 corresponding to y naught. So putting these three values in this first order derivative expression, you will get the result of y dash, and then putting the value of delta square 24, delta cube 6 for this second order derivative, you get the value of y double dash, and you can easily compare your approximate result with the exact result, because the exact function for the polynomial is given, which is y is equal to x cube plus 2. Now this is also home task for you. There is another example to find the first order and second order derivative of the function tabulated at the point x is equal to 50 based on Newton forward difference formula for this data. These are the values of x, and the step size between this data is 5. For x is equal to 50, the value of y is 1.6990, and for x is equal to 55, the value of y is 1.7404, and the value of y at x is equal to 60 is 1.7782. Similarly, the value of y at x is equal to 65 is 1.8129, and you have to find the first order and second order derivative of the function at x is equal to 50 on the basis of Newton forward difference formula. So dear students, using first order differences, using Newton forward difference interpolation formula, and taking the first order and second order derivative of the formula, and then find the value of x naught for p, and the value of y naught, the value of delta, delta square, delta cube, and so on, and then putting these values for the y dash and y double dash, you can easily find the value of y dash at x is equal to 50 and second order derivative at x is equal to 50, and then you can easily compare your approximate result to the exact result, because this is the exact function. Find the first order and second order derivative of this function y is equal to log x base 10. Taking the first order derivative and second order derivative of this function, and then putting the value of x 50, easily you get first order derivative and second order derivative of this function at x is equal to 50, and then compare and verify your approximate result with the exact result. And if there is some error between the exact and approximate error, you can easily find the errors, and you can find the errors, subtract the approximate result from the exact result, you can find the errors. And this is the end of this segment. Thank you. Allah Hafiz.